Chemistry, the magical world where atoms get together to party like it's the periodic table prom night. Let's break it down in a way even oxygen and hydrogen would high-five each other over. First up, we've got atoms, those tiny, invisible building blocks that are like the Legos of the universe. They're the cool kids at the science party, always mingling and making bonds with other atoms to form molecules. Now, let's talk about those molecules. They're like the cliquey groups in high school, sticking together because they've got chemistry literally. Whether it's water molecules cozying up to each other or carbon dioxide molecules causing trouble in the atmosphere, they're always up to something. And don't even get me started on reactions. It's like watching a chemistry soap opera unfold. You've got your reactants, those drama queens who can't wait to mix it up, and then bam, suddenly, you've got products, the aftermath of the chemical shenanigans. It's like the climax of a blockbuster movie, but with test tubes instead of explosions. Now, let's add a little visual flair to this chemistry fiesta, with some drawn formula pictures. Picture this: a carbon atom strutting its stuff, surrounded by oxygen atoms, all holding hands and singing Kumbaya. Or how about a sodium atom making eyes at a chlorine atom across the lab, ready to make some salty chemistry magic happen? So, there you have it, folks. Chemistry, where atoms mingle, molecules party, and reactions unfold like the juiciest gossip in town. It's the science of surprise, the art of attraction, and the comedy of errors all rolled into one delightful package. Keep calm and chem on, my friends. Embrace the chance to study now, as your success solely depends on you. Seize the opportunity, and let your determination and effort pave the path to knowledge and greatness. Remember, do the things to yourself because nobody else will. Topic: Molecular structure and bonding example. Consider the molecule ethane, C2H6. Ethane consists of two carbon atoms bonded together by a single sigma-A bond. Each carbon atom is also bonded to 3 hydrogen atoms, resulting in a tetrahedral molecular geometry around each carbon atom. The structural formula of ethane can be represented as follows: HCCH. In this structure, each line represents a single covalent bond, and each carbon atom satisfies its tetravalency by forming 4 single bonds, 2 with hydrogen atoms, and 1 with another carbon atom. Exercise 1. Draw the Lewis structure for the molecule methane, CH4. Explanation. Methane contains 1 carbon atom and 4 hydrogen atoms. According to the octet rule, carbon will form 4 single covalent bonds to satisfy its tetravalency. The Lewis structure of methane is HCHH. Each line represents a single covalent bond, and all atoms have a full outer shell of electrons, satisfying the octet rule. Topic: Functional groups example. Consider the functional group known as the hydroxyl group, O. This group consists of an oxygen atom bonded to a hydrogen atom, forming a polar covalent bond. The hydroxyl group is commonly found in alcohols, such as ethanol, CH3CH2OH. In ethanol, the hydroxyl group is bonded to one of the carbon atoms, imparting characteristic properties to the molecule, including its ability to participate in hydrogen bonding. Exercise 2. Identify the functional group present in the compound ethanoic acid, CH3COOH. Explanation. Ethanoic acid, also known as acetic acid, contains a carboxyl functional group, Cu. This group consists of a carbonyl group, C=O, bonded to a hydroxyl group, O. The carboxyl group imparts acidic properties to the molecule, and is commonly found in organic acids. Topic: Isomerism example. Consider the isomers of butane, C4H10. Butane exhibits 2 structural isomers, N-butane and isobutane. In N-butane, the carbon atoms form a linear chain, whereas in isobutane, the carbon atoms form a branched chain. Both isomers have the same molecular formula, but differ in their structural arrangement. N-TEXT-butane, CH3CH2CH2CH3, isobutane, CH3CH3CH3. Exercise 3. Identify the type of isomerism exhibited by the compounds cis-2-butene and trans-2-butene. Explanation. Cis-2-butene and trans-2-butene are geometric isomers, also known as cis-trans isomers. They have the same molecular formula, C4H8, but differ in the spatial arrangement of atoms, due to the presence of a double bond between two carbon atoms. In cis-2-butene, the substituent groups are on the same side of the double bond, while in trans-2-butene, the substituent groups are on opposite sides of the double bond. These examples and exercises demonstrate fundamental concepts in organic chemistry, including molecular structure and bonding, functional groups, and isomerism. Understanding these principles is crucial for elucidating the behavior and properties of organic compounds. Absolutely. Don't forget to show your support by liking, sharing, and commenting on this video. Your engagement helps boost its visibility and importance, allowing more people to benefit from the content. Plus, subscribing to our YouTube channel ensures you never miss out on our latest updates and videos. So, hit that like button, share with your friends, leave a comment, and subscribe today. We value your feedback and interaction, and we'll do our best to respond to each comment and address any questions or suggestions you may have. Let's build a vibrant community together.